Got it. Okay. Thank you, everyone. Welcome to the IDS 28 Global 5G Evolution. To the audience there, please take a couple of seconds to click the subscribe button. Welcome to the speakers from all around the globe to join us to present on the technology of 5G with the latest trends that's going around in 2022. Without due delay, let me introduce Ali Murtaza from Riyadh, Saudi Arabia, to present on the 5G private network and edge cloud.
Thanks, Ganesh.
Over to you.
Yeah, thanks, Ganesh. Let me share my slides. Okay. I hope it's visible to everyone.
Yeah.
Yes.
All right. Hello, everyone. It's really an honor to be among
Betul, connectivity only lagi.
Sorry.
Please
Guys, can you hear me? Can you hear me?
Please
Okay, carry on. All right. Hello, everyone. It's really an honor to be among industry best brain. And today I got an opportunity to present you a session on 5G private network and edge cloud. So what I did for this session is that I arranged this session in a way that I will not only be touching the technology, but I will be talking about some of the operation and the business aspect as well. So before I start, let me quickly introduce myself. My name is Ali Murtaza. I'm cloud solution architect in one of the leading operator in the Middle East. I have around about 17 years of experience, out of which most of my experience works. For the last 4 years, I've been associated more with the cloud computing and edge computing. I have an honor to be working in the vendors like Huawei and Ericsson, and I have been attached to operators in a different market like European Union, MENA region, and South Asia. So this is pretty much about my introduction. Let's move on. Okay, let's start from the very basic definition of multi-axis edge computing. So we have to understand one thing is that multi-axis edge computing is not kind of a complex technology. Rather, it's a way of architecting your network in a way where you take your computational capabilities and IT application infrastructure closer to the user. So it's more of extending your cloud capabilities to the edge of your network. And what you get in return is the latency. So when I'm talking about latency, it's not something, a network API that will be improved after this setup. There is a big deal which is associated with this one. So this high value of latency, which is a small latency value, will help us to virtualize our equipment in the future. So the devices, the terminals, or the tablets that we will be seeing in future will be very lightweight. They will be having a more processing power. They will be having higher battery time. But on ground, those devices are like mostly the dumb devices, because most of the processing that being done will be happening on the network edge. So this is a very key catch that we have to understand, that how latency is too much important, because we don't want the user to feel like that it is not happening on the device. We should have kind of seamless behavior. Talking about the key business drivers for the edge computing, for sure, it's low latency. Other key drivers includes higher bandwidth, lower transmission cost. In order to achieve this key business driver, there are some add-on benefits that we'll be getting out of it. That includes data sovereignty, control authority, data security, customers' privacy, wireless fiber experience. These are the add-ons that will be help us in paving our way towards 5G private network. And I will be discussing this one in a while in my upcoming slides. So talking about the applications that we have today, which we are serving them from the central DCs. They are good. They are pretty much working with the latency value of 30 or 40 millisecond, and they are serving the current requirement. However, the next generation application or the advanced application, we will be targeting latency something below 20 millisecond, and in some cases below 1 millisecond. So we have to prepare ourselves for this new wave of change. Talking about 5G technology, uh, the most common use cases that we have are the fixed wireless access and enhanced mobile broadband. They might not be sufficient to justify our investment, our 5G investment. So we need to explore some new markets, some new verticals so that we can have maximum out of our investment. And 5G private network is something that will give us this opportunity, and you will see in the upcoming slides. All right. In order to understand the multi-axis edge computing, it's very important that we need to categorize them, because what I have seen that there is a lot of confusion, because of the reason that we are not discussing each edge computing separately. So there are two main categories of edge computing, and both categories have their own separate target segments, and they have their own dynamics. So we have to look each edge computing with the different canvas, with the different spectacle. So talking about the first category, what we have is on-premises edge, which is generally known as a private edge. This is kind of an edge computing where we try to build an edge data center in the customer premises. So together with the connectivity, we build application infrastructure and we serve our customer. This is for the verticals, for the enterprises, to give them a kind of a seamless environment as if they have owning their own private network. This mostly fits for the enterprise or B2B enterprise, and this is mainly targeting big enterprises. Talking about the second category of multi-axis edge computing is a network edge, which is generally known as public edge. This is kind of edge computing where we deployed our edge center on the edges of our network. If I'm talking from the perspective of operators, because operators have distributed networks, so they extend and they try to put or build a computational capability closer to the user, but not very close or not in their premises. This kind of edge computing has different target segment to be hit. This will be covering the enterprise like B2B, but small and medium enterprise mostly. And mostly this kind of an edge computing will be kind of helping applications which required a complete rollout over the whole countrywide. This is a tricky subject. There is a lot of investment being involved with this kind of edge computing. One of the facts that we have to understand is that we don't have kind of major killer application for this kind of edge computing or this category of edge computing, except for cloud computing that we can see. So, but operator has to build their network for this new wave or new change. Moving on further, let's have a look at it, the value proposition of these two different categories of multi-axis edge computing. So we can see from these two edge computing that there is a huge impact that they both will be created. But fact of the matter is that the first category, which is on-prem edge, has an advantage in terms of amount of effort to be done, because this is an easier opportunity to be addressed, because there are enterprises and the enterprises somehow have a well-defined scope. So operator really knows what to do, what kind of application use case that needs to be served over there. The second category is also very important, the network edge, but the thing is that the amount of effort that requires to be done is much more higher. So the business opportunities or the main use case, there are a bunch of use cases, but some of the use cases common in both of the edge computing categories, while some are specific to a particular category. Like talking about industrial 4.0 automation, this kind of opportunity is specifically to the on-prem edge. cloud gaming, AR, VR, V2X communication, HD video. These are the kind of a use case or business opportunities that is more linked with the network edge. Uh, we will try to focus ourselves on the first category, which is the prime subject of our today's session. So from now on, we'll be talking about the on-prem edge or the private edge. On-prem edge. So the rising demand of IoT application and the industrial 4.0 evolution has positioned this private edge in a spotlight. And this kind of edge computing is generally known as 5G private networks. In 5G private networks, there are various branding names that being used by the vendors, by the manufacturers, depending upon their understanding of perceiving the concept and depending upon how the strength or what are the market segment that they are actually looking. So I have seen the terminologies like virtual network campus. This is something that being pretty much used by Huawei. Smart campus is another terminology that Huawei probably is using this one. Other terminology includes private MIC, which is pretty much used by Microsoft. There is non-public mobile network terminology. This probably be used by most of the disruptors. Ericsson uses a terminology 5G in a box. 5G private campus is a terminology coined by Nokia. So there are a number of different buzzwords around the industry. So the next time when you will see that these kind of terminologies being used, don't get yourself confused with that one. These are the brand names of the same technology, and the technology pillar that we are discussing is a private edge actually. One terminology which is very important is a non-public network. This is terminology being chosen by 3GPP, but I have not seen this terminology pretty much used by the industry people over here.
Hi,
Moving
Ali,
on
due
further.
to the
Yeah,
time concern, due to the time
yeah.
concern, able to wrap up the session.
Okay. I will try because there are a lot many slides to cover. Okay, I will try my best to cover as much as I can. So one of the potential use case for the 5G private network is the enterprise business. So 5G private campus provide a very good opportunity where these enterprises could have high reliability and resilience. They can have the high throughput and high bandwidth, and of course latency, because the data will be processed locally within that one. Security and integrity is another add-on which they will be getting out of it, because of the reason that they have the assets to be placed on their premises and the data is with them. Another potential market for 5G private network is the mission critical networks in the public safety domain. Reason behind why the 5G private networks is a strong contender for these mission critical network is that the existing networks that we have is narrowband. We have these systems, the mission critical systems are mainly based on P25 or Tetra, and which require modernization. And the use cases that we have seen in the public safety domain is no longer being associated with just a narrowband or just a voice communication. So 3GPP, they were well positioned into that one, and they were forcing this opportunity and they were targeting this one. So from release 12 onward, we have seen these features were being incorporated. So we have seen URLLCC standard specification being included in release 15. In release 16, we have seen TSN to be included, while in release 17, there is IoT and URLLC are the main subject under discussion for the standardization. Let's dissect the private networks quickly. There are two main parts of that one. One is the network connectivity, and the second one is the edge application hosting. Let's see one by one. So the network connectivity, we can see that there are multiple options we have which an operator can offer to their enterprise customer. So there are full private network, they can offer it. There is a radio access network shared option that can be also provided. There is a third option where we have radio access network and the control plane is shared between operators and the private networks. There is another fourth option which is N3 local breakout, but this is not something pretty much used in the industry. Another very tricky subject where we have seen there is a split in the industry is the application hosting. So I have divided the solution available within the industry into four main categories. The first one is the HC compliant solution. So ETSI, who has defined the specification for the network function virtualization, they came up with one blueprint where they are doing this lifecycle management or orchestration of the application. We have seen that the vendor like Huawei and Nokia are pretty much convinced with this approach, and they have prepared their product ready for that one. Other vendors like Ericsson and Cisco, they believe on the connectivity morely, and they see that application hosting should be on infrastructure as a service approach or IaaS approach. While the connectivity, they are pretty much comfortable to provide that one. Hyperscaler on the other side, they are targeting this opportunity with their own proprietary solution, and they are also providing the same infrastructure as a service kind of solution. Some of the vendors like Nearby and Mobile Ajax, which has been recently bought by the Google, we have seen that they have their own proprietary solution. So they devise their own way how to have onboarding of third-party application, recycling of that one, and orchestrating of these application. Let's quickly talk about the network, 5G private network monetization.
Ali,
Yeah.
I think I have to stop you. I'm sorry because I got to time keep with the. So thank you so much. It was a brilliant presentation. I appreciate it. So maybe we'll take you up for the next to continue for the next session next month. Thank you so much, Ali. I appreciate it.
Okay. Thank you so much.
On,
thank you so much.
Yeah, I would like to pass on to the next speaker, Saad Sheikh from Melbourne, Australia, to present on 5G operations using data and AI.
Hi guys, thanks for having me. Just a quick check. You can see my screen?
Yes, sir. Are you able to enlarge the full?
Yeah, absolutely. And first of all, thanks for having me. About my very brief intro. My name is Saad Sheikh, and I lead a small but very efficient global team within Dell. And my team, I am responsible for the multi-cloud automation and the AI ops. So we are bringing a number of solutions in the telecom space. Prior to this, I have 20 years of experience. In these all years, I have been working with many global players. I was the VP for Southtel in South Africa. I was leading the automation business with Willow Consulting in UK, leading in large-scale projects in Germany and across. Before I was the chief architect with STC and a lot of other engagements. One more thing, I also work as part of the Dell CTO team, where I lead all the Dell's liaisonships towards Linux Foundation. So most of the stuff around cloud and automation, so we are active part of it. And we really want to see how we can solve these broader issues. And it's very quick slides. Actually, I will not be going much on the marketing or all this jargon side. Just first, I want to touch on the key architecture and principles which telcos are using to build the 5G networks. And obviously, the focus is more towards the cloud native or SA core, but more or less the same will be applied across as well, right? The key thing I just want to share we have been focusing during the early phases, which could be aligned with till the 5G release 15 or maybe till the release 16 early SA deployments, is mostly about the disaggregation and using different cloud models, as well as trying to find a way to deploy, right? And obviously, the industry jargon is to use a nice terms like a DevSecOps, but obviously we all know, right? When it comes to a telco cloud deployment, there are unique asks in terms of both operational processes as well as the tool chain, which needs to integrate largely with the legacy networks. And again, this is a broader topic. And in today's session, I will be more focusing on how we will enable or automate all these platforms on the top, right? In other words, how we can bring the man-machine incarnation into the networks, right? Like what will be the right approach, use cases, and solutions to enable AI that gives up business outcomes, right? And just to touch it, I just will be very quick to show where we are heading. As we all know, at the end of 2022, we are expecting more than 1 billion 5G subscriptions. And it really needs that we have to prepare ourselves for 5G scale. And all of this journey primarily we can understand from the three main narratives, right? One is a classic as a service model, right? Because customers don't want to lock them up with a particular vendor, with a particular solution, right? So even if you talk in terms of solution, right? Whether edge is a separate solution, whether edge is a cloud, whether you should hyperscaler. So all of this should be a customer choice, and it should not be defined by a vendor, and it should be an outcome-based choice, right? If you are, if let's say for a case, Google gives you a business outcome, then as a vendor or as a partner, this is our mandate to enable into it. So I think that's an important piece. Again, on RAN, should you use to a RAN, ORAN, or vRAN, or even if you want to keep the legacy RAN, right? How you can make maximum value out of it, right? So I think that's the first direction. The other is obviously the business outcome. I think this is something many of the operators have not really talked about, or in other words, not lead this way, right? Because sometimes we want to use latest technology, but if this latest technology can't be monetized, right? So ultimately, this is a break point. So it's really important how we can onboard the enterprise and the vertical market. And most important, with scale, we need to find a way how we can really manage this scale, right, of this, all of these machines, devices, so how we can really automate those networks. So that has been the prime journey for 5G. We are looking forward. And then it comes to the right operational model, right? So it's very important that when you are building or defining the operations of 5G, you take all those parameters into consideration, right? The first, obviously, is the new use cases or the vertical market approach, because each of these require a different requirements. So it's not about tell what is telco operational model and imbue into the verticals. It's gonna vice versa. Then obviously how we can use the multi-tenant networks, right? Whether through slicing or NAS and all those automation architectures. And the service operation layer, again, as we'll talk about, is the key if you need to monetize anything on the 5G, right? Otherwise, obviously, after the eMBB or broadband services, there is hardly the narrative to sell something extra. And lastly, and most importantly, service assurance and the visibility, right? So it's very important that we automate network in a way to enable the seamless and real-time observability and assurance systems. And how we are trying to stitch all of those challenges and requirements of our customers to the different architectures. Really, it's about defining a journey, right? Because if there is one lesson that we have learned from the cloud and all this orchestration, is there is definitely no one stop to reach the target goal, right? So in the first top, you can really see in terms of the monetization, right? Like what is the real break point, which is the charging the 5G investments, right? To very quick pass on this, as you all know, right? We build the telco clouds, we build the workloads, but they are not properly interworked. Again, when I talk about interwork, I don't talk about the technical IoT. I more talk about business outcomes, right? Because you have separate teams, each want to drive, and then we find that the overall solution is not optimized. So it's not giving you the cost for your investment, right? Life cycle, again, is very tricky part because you can deploy a solution, but with all of these changes and operational stuff, right, you always find issues. And again, the time and cost and ROI, if you are a finance guy, that's an important piece. And not aligning your 5G or any of these architectures to the delivery outcomes means you need to redo a lot of work. So again, there is a lot of mundane and I should say laborious tasks you do over and over again. And finally is about the seamless support of the data-driven and AI ops. So I think that's very important as we move around. If we really need to monetize in the incremental steps, we need to address all of those things. And in terms of the scalable 5G rollout, again, what is our approach to address those? Obviously, first is the supporting the telco workloads ready state. So again, giving our customers choice to use any of the app, right? Any of the service layer tools, but we want to really make it workload ready. So you no need to find a difference of opinion between the infrastructure and application. And life cycle management, especially day two, right? It's very, very important, and enabling a complete as a service and efficient cost model is the other main thing what we are doing. And finally, what is the right data architecture? Really, really very important, right? It's not about you build an infra, then integrate the event and telemetry upstream. You really need to find the right data architecture if you really need to monetize. And that is what we are actually working on. And obviously we have learned a lot based on the deployments in the APAC. And this is overview on the enabling the multi-cloud. So as you can see, forget about the infra pieces, because as per customer need or ask, it can be a variable, right? Most important is you get a fully integrated stack, right? Whether it is a core or an edge or a RAN, and it has a service wrapper, right? So it means you will have not a separate support vectors between the different vendors, but you will get the complete SLA, lifecycle management guarantee, supply chain advantages, and a fully integrated stack, right? So obviously it means the whole of these layers need to integrate well, and not only itself, but obviously in terms of the API integration and service assurance on the top. So this we really believe is the first step if you need to really make a journey towards a intelligent networking. But again, no lock-in. So depend on the different use cases, you can have any choice of any cloud partner or any hardware in cases as well. Just want to touch that as we will move. Ideally, the 5G or the cloud journey was about the softwareization of the industry, but really we see that for the telecom networks, there is a more and more need of a deep silicon, whether is a form of the inline accelerators, whether is a low-side, all of those DPU and GPU advancements. This is mandatory. Even if you see, if you need to make some AI or quantum computing workloads, really you need very fast processing. You see the NVIDIA, they just launched AAT and other processors. So it's very important that how you can really use an efficient hardware that can give you the right cost equation, right? And this is very important, and all of those devices you can enable as per your choice on the platform.
Just a very quick, due to the time concern, would you be able to wrap up, please?
Yeah, I will just have 2 slides. So just 2 to 3 minutes, I will just wrap up. Is it okay? So just a very quick summary on this. This is the overall summary. Again, some summary coming over effort within Linux Foundation. So we can see today we see the overall market and the gaps in the infra and the automation. So there are really many of the issues already addressed, right? But still we see there are some real gaps that we need to solve in order to do the full automation pipeline, right? I am not trying to go through it, but maybe in a separate session, we can touch all of those. But the way obviously we want to enable is the smart tool chain in order to do the full scale automation. It's very important, right? That across the complete life cycle, whether it is starting from a customer or vendor or a staging lab environment to production to operation, right? It is a full integrated approach, right? For this session, I will be just touching on the feedback loop, right? It's very important that you build a solution that has the right data architecture to feedback the data and optimize it across all of the environments. So I think that's the key summary of it. And again, one of the things what we are trying to work and bring forward to the industry, again, this is one of the architecture we are proposing to Anuket Thoth program, where I am one of the contributor, is around how we can define this integrated stack, and then we can integrate all of the events upstream. So what is the right structure of this data platform, right? Because above this, right, it's more about the data science issue, but here is a complete cloud and infra issue, right? Like what type of data should be integrated, how we can interwork with the workload on application, and obviously how we can automate the service assurance. So primarily that's the key direction we think, which can really enable us to enable multi-cloud platform, enable the right data architecture, and then enable the ugly use cases, primarily on the anomaly detection and fault detection and resilience of the network. So, yep, that's roughly from my side. Thank you very much, guys. Thank you.
Thank you, sir. That was excellent. I appreciate that. Now moving on to the next speaker, let me introduce Trisha Lim from Singapore to present on the co-creating solution with 5G ecosystem.
Thank you, Kanesh. Let me share my slides. Let me know if you have problems seeing my slides. So anyway, good afternoon, good evening. Thank you for inviting me to join these sessions together with so many of you, the industry like-minded. My name is Trisha. I'm from Axis Communications. Axis is a Swedish company who specializes in IoT solutions and security solutions. So we are the world leading manufacturer in network video and IoT audio systems. So as a leader in network video and IoT solutions, we are really excited by the promise and development of 5G. We see growing opportunities enabled by connecting. Sorry, you are seeing my slides.
Yeah, but the speaker view. Can you go to the display setting?
Can you end the slideshow and then share the screen? There's going to be a few screens that open up. One is just for you, and then one is for us.
Oh, okay. Sorry.
Selected the whatever you selected last time. Select a different screen. The PowerPoint also opens.
Let me do it again.
Great. Okay. Then if you press present now.
Yeah.
Not
I
yet.
think
Not
you're
yet.
still.
Yeah, Tracker, what you need is to select the extended screen, the second screen you have.
Yeah.
I think you're using multiple display, right?
You can click display setting and swap the screen. Display setting.
Sorry. Display setting.
In the middle.
Zoom?
Yeah, no, in your PowerPoint.
Okay.
Okay, and swap. Yeah. Okay.
Is this better?
Yeah.
I'm sorry, because the Zoom bar was hiding it. Sorry. Yeah. So I was saying that, as a leader, we are really excited by the promise and development of 5G. We do see growing opportunities enabled by connecting IoT devices using 5G. And we believe that it's really important for different players to come together to co-create, to ideate, to co-create, to even validate the solutions together. I think Ali and Sab mentioned earlier on about the journey. about the use cases. I think, so this is where I'm actually going to share in the last few minutes. Okay. So I think with 5G, we do realize that, it introduces a new innovations possibility, which go beyond today enterprise limitations. So the ability to connect devices and machines to secure, reliable, and optimize network from any place and any time is enabling us new way to work, to think, and also to solve traditional business challenges. When we look into the benefits of 5G, for businesses, we actually do see some common characteristics. For example, it can run on any process. It can run any process remotely, regardless of how critical it is. It has actual real-time and control of every business process. Its operations are automated. It also uses compute resources where it makes sense. Running applications on the edge where relevant. It also has an inherently higher security level without sacrificing over performance. So what does it mean? I think we also see that, I'll explain that in my next few slides. I think that said, 5G is rapidly becoming, I think, the world #1 catalyst for enterprise digital transformations. So where do we begin to show this value? We believe the journey to 5G success is not one that, can be taken alone. To us, 5G is a connectivity, is an innovations platform. We will need innovations or use cases to monetize this. And this require an ecosystems to come together. And we believe collaborations is really key in this case. You need 5G technologies provider to provide the connectivities. For example, like the telco or the telco ecosystems, the IoT device manufacturers such as Axis to provide the sensors, platform providers to congregate the data, software analytics vendor to do the sense making, consultant to build, to advise the solutions, and then the SI to put the solutions together. So last but not least, while we can all do this together, we also want to have the customers who endorse the business case and to deploy the solutions. We have a very good example of how the ecosystems work together in Singapore. We are part of the 5G industry partnership led by Singtel, which is one of the largest mobile network operators in Singapore, and also with Ericsson. So what's the objective of this industry partnership is to actually leverage the expertise of each partner from different industries to come together to co-create. So for example, in this industry partnership, we actually have like software vendors. We also have hardware vendors like us. So for us, we have already started doing trials using our cameras and also our audio systems connected through Singtel MEC network. So in that sense, we are also building solutions together that address the new security or safety demands for cities due to the current pandemic. So on this trial, we are also currently studying the potential of 5G, looking at different use cases. For example, how does it make mass detection better, social distancing better, or even using audio for crowd management at different locations. So other than the trials that we're doing in Singapore with Singtel and Ericsson, we're also seeing trials and pilots sprouting from different segments. For example, governments and law enforcement rely heavily on information. So it's not just any information, it's also the right information at the right place, in the right time, in the right hand of the right people, especially when we're talking about any seconds of disruptions or delay can often have huge consequences for any first responder or security operations. So fast and reliable connections is key to make sure the informations are going in the right directions. So I think no one knows better than this than our security or public safety professionals. So with 5G, we do see that they could utilize 5G-enabled cameras and sensors to receive near real-time information that can help them to effectively respond to the scene of an emergency. We could also connect sensors or wireless networks such as drones or body-worn cameras together and relay information as quickly as possible. Secondly, I think the availability of 5G in city also give an opportunities to the urban mobility, allowing cities to, I think, modernize and make their transport systems more efficient. So with access to 5G, cities will increase their ability to improve public transport operations and planning. For example, introducing dynamic transport planning, meaning they are able to track the number of passengers that are waiting for buses and to deploy the respective fleet of buses to meet the demand of the passenger, and thereby reducing traffic congestions. And also it could also be a way to relocate space to other mobility users, such as like other drivers or even cyclists or pedestrians. So we also see that there are also trials, pilots that we're running with manufacturing plants. So as you know, manufacturing plant is a highly complex environment. Advanced machines and robots are equipped with a wide array of sensors, such as cameras that are connected to high-powered analytics engines that react to supply and demand. So in other words, the manufacturers needs to maintain a wide product portfolio to meet the diverse and demanding needs of their customers. So there's a need for running flexible productions to accommodate rapid changes to the production environment. So eliminating the need for wired connectivities, we believe that 5G will supplement the high-speed manufacturing environment with a far greater degree of flexibility. On top of that, I mean, we also see that the additions of sensors to multiple machines means that factories are creating more data than ever before. So transmissions through wired network is expensive to scale, and that 5G has the ability to support high connections density with tens of thousands of endpoints, which truly enabled the use of industry data at scale. I think these are a couple of examples in manufacturing, transport, and even in law enforcement. We are also working on cases from ports, from oil and gas infrastructure, and also agriculture in the region. So lastly, I think, as I mentioned, we believe that, as a IoT solutions provider, we see that, for 5G to be successful, partnership is really core. And at Axis, we have a long history of partnership. I think since we launched the first network cameras in 1996, we have recognized right from the very beginning that, collaborations is a key differentiator and driver for our business. So over the year, we have built up a very big pool of partners in both hardware and software that we can count on to address customer needs. So we also make the decisions to create open platforms to allow greater flexibilities and creativities by adhering to industry standard and making our APIs available. So it's a bit, I'm doing a bit of selling Axis here, but again, I think this is to emphasize that we are really big on partnership, and we believe that 5G success will really depends heavily on industry players and customers coming together to brainstorm, to co-create and to test. Again, 5G infrastructure itself is not going to deliver any magic without actual use cases being deployed, tested, and scale up. We are not a network expert here, neither are we a cloud expert. So but then we are an IoT device expert here that can be part of the solution. So if any one of you have any ideas, we do look forward to connect and also to discuss and see how we can actually co-create together in this journey. Thank you. Kanesh, back to you.
Great, Trisha, thank you so much. Appreciate it. Fantastic. So moving on, let me introduce the next speaker, Riza Bakhtiar from Jakarta, Indonesia, to present on 5G smart manufacturing. Over to you, Riza.
Okay, thank you, Ganesh. I would like to share my screen first. Wait a minute. Okay, can you see my screen?
Yes, sir.
Okay, thank you. So let me start it. First of all, Allow me to introduce myself. My name is Reza Bahtiar from Enterprise Solution Management, segment manufacture, transportation, and logistics from Telkomsel, Indonesia. And I would like to share with all of you about the 5G smart manufacturing. First of all, before we are going to explore more about what kind of the solution in smart manufacture, we would like to explore and understand about the challenge and opportunity that face with our friends in manufacture. Like in OT technology, there are a lot of ways. There are 7 ways of lean if we are exploring about lean manufacturing, and there are a lot of opportunities that we can elaborate and collaborate with the 5G network in industry. And we already identify that the current common problem in manufacture, the first is the inconsistency of the labor performance. And then the second is the manual data collection process that the employee or the operator in shop floor still collecting the data manually. And then the third or the less common problem is the discrete improvement that already implement in manufacture. So there are still a lot of silos in manufacture, but if we can integrate and collaborate with the 5G connectivity, I think it will be beneficial for the manufacturer. So what kind of the benefit that we can get if we collaborate with the manufacturer with implementing of the smart manufacturing solution? We can increase the safety, reduce the risk of the injuries and accidents, and also we can increase the efficiency, like in inventory and the cost of operation. And then we can also increase the productivity, for example, for production output and the machine utilization. And then besides the direct impact of the benefit, we implement smart manufacture using 5G, we can get also the tangible benefit and intangible benefit. Like there are a lot of benefit we can get. For example, like the direct impact is for the minimize the operating costs, and then for the intangible, we can improve the staff retention and the satisfaction of the employee. And as we know that in Industrial 4.0, there are, based on McKinsey, there are 4 specific category for Industry 4.0. First is connectivity, data, and computational power, like sensory devices, IoT, cloud, blockchain, 5G. The second is the analytics. And the third is human-machine interaction, like collaborative robot, automation, and so on. And advanced engineering, like additive manufacturing, such as 3D printing, nanoparticle, renewable energy. And 5G positioning in manufacture is as enabler, like we provide digital connectivity and then digital platform and digital services that running above the 5G network. So we are not only talk about the connectivity, but we are exploring also about the what kind of the services we can run and we can implement above the 5G connectivity. And also we can orchestrate other platform and application that can integrate with the 5G network. And as we know that a lot of manufacturer, a lot of company prefer to implement 5G private network. So we propose the integrated private network, like still collaborating with the public networks. And the second is the independent private network. So it is dedicated private network for the customer. And what kind of the application or the use case we can implement, such as labor augmentation. We can implement augmented reality or the virtual reality, and then for the mobile and robot or collaborative robot in the shop floor and production And we can also implement predictive maintenance with the 5G, low latency, and improve bandwidth. We can implement a lot of sensory devices and high-speed bandwidth. And then we can also implement in the warehouse, such as automated guided vehicle, so it can increase the productivity and effectiveness of the business process from the production to the warehouse. And then we can also implement connected tools and machine vision, such as computer vision for the visual inspection in quality control. We are already mapping the supply chain of the manufacture process, but it is still can be specified because different industry can be different supply chain, value chain, and different company can be also different value chain that implemented in the industry. So it is very high customization in manufacture, but I think we can also implement a lot of use cases, such as if we provide the solution from the inbound process, from the supplier or the contractor to the manufacturing process in the production line, up to outbound process to the warehouse, and we can also implement to the end customer. So this is the one of the category solution that we can implement in the 5G network in smart manufacturing, like digital smart warehouse, asset performance management, and a lot of kind of the solution in how we can integrate the operational technology with the information technology so it can be converged into one solution. I think that's all from my presentation. Feel free if you have any question, and thank you, Kanes, for having this session. Over, back to you.
Thank you, Reza. That was brilliant presentation. I appreciate that. Moving on to the next speaker, let me introduce Jan Stryjak from London, UK, to present on the 5G becomes dominant global smartphone technology. Over to you, Jan.
Hello, thank you very much. Right, let me share my screen. All right, hopefully you can see that okay.
Yes, sir.
Brilliant. Okay, well, hi everyone, and thank you very much for inviting me along. So, yeah, I'm Jan Stryjak. I'm an associate director at Counterpoint Research. We are an analyst agency that looks at the tech sector, so smartphones, IoT, wearables, all that kind of thing. So really, some really fascinating presentations so far, but I'd like to bring it back to basics, really. So smartphones may not be the most exciting 5G topic, but it's probably the largest global deployment of 5G technology. So I think it's worth talking about, and especially now that 5G has become the dominant smartphone technology globally. So obviously 5G launched towards the end of 2019. So in just 2 years, 5G has become the dominant smartphone technology, as I mentioned. So in Q2 2022, 5G smartphones accounted for 50% of global smartphone shipments. So now, obviously, that's still a long way to go in terms of the installed base. So 5G adoption in terms of the installed base is still a lot lower. But as the 5G smartphone shipments grow and existing non-5G smartphones are replaced, 5G in the installed base will continue to grow. But what I'd like to do in this presentation is give a little bit of detail behind this as to kind of how 5G smartphones have managed to grow so quickly. Now, this data point to Q2 2022, 50%. That's fresh off the press. That's only in the last few days we've completed that number. So the numbers in the rest of my presentation are Q1 2022, and we'll have more detail on Q2 over the next week or so. So when we look at 5G globally, obviously there are different regions where 5G is more prevalent from a smartphone perspective than others. So here we have on this chart, so 5G smartphone shipments penetration by region. And we have three regions or kind of areas where 5G dominates. We have Northeast Asia, so China, Japan, and South Korea, where together, as of Q1 2022, 5G smartphones accounted for 81% of shipments. Then we have North America, where it was 75%, and Western Europe at 69%. Now, these are obviously advanced markets, so this probably comes as no surprise. In terms of the rest of the world, the more developing markets, more emerging markets, 5G adoption is still a lot lower. So we have Eastern Europe at 37%. We have the rest of Asia. So apart from China, Japan, and South Korea, rest of Asia at 27%. We have Middle East and Africa at 15%, and then Latin America at 13%. So quite a lot of variation across the world. But as you can see, still growing quite strongly. There are, as you may notice, a few dips in Q1 in Western Europe, for example. 5G adoption dipped compared to Q4 2021, but that's because of the iPhone effect, which I will come on to in a bit. So in a bit more detail in terms of the countries, so one of the big milestones we reached in Q1 2022 was that Japan and USA joined the 75% 5G club, as we like to call it. So where 5G smartphones accounted for 75% of total smartphone shipments. So 14 markets across the world have now reached that 75% penetration. And you can see that in the table on the right. And I've sorted these in terms of how quickly they reached that 75%. So at the top, you can see Canada reached 75% in only 5 quarters from launch, Denmark as well in 5 quarters. So US finally passed that 75% in Q1. So that was 12 quarters after launch. So far, it's been the slowest to reach that 75%. Japan is somewhere in the middle with 9 quarters. Now, a bit interesting here, so you can see the current 5G percentages on the right of the table there. Now, some of these have dipped below 75% again. Singapore, for example, has dipped to 70%. Sweden has dipped to 67% in Q1. Again, this is mainly because of the iPhone effect, which I'll explain in my next slide. But just quickly, one thing to note here is there are a few markets that we expect to join this club, the 75% club, in the next quarter or so. So there's the rest of Scandinavia being a particularly advanced region. So we have Finland, which is currently on 71%, and then Norway, which is currently on 67%. These are 2 markets that are generally fairly advanced when it comes to mobile technology, when it comes to internet connectivity. So they won't be long in surpassing 75%. And then there's New Zealand as well. So Australia, you can see, already has passed 75%. It's now dipped to 72, but it has passed. And then New Zealand is currently on 73%. So it should be in the next quarter or so passing 75%. So in terms of which OEMs are kind of leading this drive, back in when 5G first launched, it was pretty much exclusively Samsung that was leading the 5G charge. So back in Q2 2019, Samsung had accounted for almost 80% of global smartphone 5G shipments. Now, Huawei had a bit of a boost in Q4 2019, and it took the lead, overtook Samsung. But then, of course, as I'm sure we all know, Huawei suffered a decline starting in the middle of 2020. So its 5G share and 5G shipments declined rather drastically. And then in Q1 and Q4 2020, Apple launched its first 5G phone, the iPhone 12. And that propelled Apple to global 5G leadership, so overtaking both Huawei and Samsung, and accounting for over 40% of 5G shipments in Q4 2020. And Apple has maintained that lead kind of since then, really. And this is where you can see the bumps in Q4. So Q4 2020, Apple had the big bump, and then Q4 again in 2021, with the launch of the iPhone 13. And this is typical of Apple seasonality, that new devices are launched in Q4, and that leads to a big bump in both Apple shipments, and then because they are 5G enabled, in 5G shipments. And this is why in the markets that are where Apple is particularly strong, like the US, for example, this is where you see that big bump of 5G adoption in Q4. And that will likely happen again in Q4 2022. But what else is interesting, I think, here is the growth in these other OEMs. So the Chinese OEMs that are now expanding rapidly outside of China. So we have Xiaomi, that is number 3 in terms of 5G shipments globally, and then we have Oppo, Vivo, Honor, and Realme, all growing pretty strongly over the last few years. And one of the results of that is that 5G is growing and dropping rapidly down the price points. So here we have 5G penetration within various price points. So on the left we have the entry and budget tier, as we call it. So for entry, we mean anything that's sub $100 wholesale. Budget is $100 to $249. So that the part of the chart on the left is anything under $250 wholesale. The mid tier in the middle is $250 to $500, and then premium is anything over $500 on the right. So what we can see, kind of as expected, really, given that 5G was really a premium technology, is that within that premium segment, 5G is pretty much ubiquitous. So in Q1 2022, 5G accounted for 97% of 5G shipments. Sorry, 5G accounted for 97% of total smartphone shipments. And that was driven, as I mentioned, by the iPhone 12, the iPhone 13, but also by some of Samsung's more flagship phones, like the S21, and then more recently the S22. In the mid tier, it's a bit more of a mix. We have the Oppo Reno 7, we have Samsung Galaxy A52s, we have the Honor 60, that's been driving 5G to now account for almost 80% of 5G shipments in that mid tier. But 5G is also growing rapidly in the entry and budget tiers. So it's now accounting for almost 20% of smartphones shipped in the sub $250 bracket. So we have the Samsung Galaxy A32 in there. We also have the Oppo A56 in there, and then the Honor Play 30 Plus as well. Now, the Honor Play 30 Plus is one of the cheapest 5G phones available. The ASP is around $150, but it does sell almost exclusively in China. But those lower priced offerings are certainly helping push the 5G smartphones down the price tiers, and therefore making them more affordable for people in more emerging markets. So in terms of ASP, this is how we see 5G ASP evolving over time. In general, it has dropped fairly steadily over the last couple of years. So in Q1 2020, it was at 673 mark. And now in Q1 2022, it was at 567. Now there's been a steady decline. In general, there are, because of the iPhone, there are bumps in Q4. So Q4 2020 was because of the launch of the iPhone 12. And then in Q4 2021 is because of the launch of the iPhone 13. Now, Apple, obviously, the devices come at a premium, they're expensive, and Apple also accounts for the vast majority of revenue in the smartphone sector. So when Apple has a big increase in shipments, that generally means that the overall ASP goes up. But the general direction, though, is a steady decline in 5G smartphone ASP. And the key reason for that is because more and more devices are now available for much cheaper. So many more devices are available for the sub $200 mark, and there are some that are even available in the sub $150 mark. So here on the right, we can see some of the key ones. So we have the Oppo A74 5G that had an ASP in Q1 2022 of around $186. Then the Redmi Note 9T the Samsung Galaxy A22 5G, and then the Motorola G50. These are some of the big sellers, and they all have an ASP of around $180. And then some of the ones right at the bottom of the price tier, we have the Realme Narzo 30 5G with an ASP of around 153. And then right at the bottom, probably the cheapest 5G phone available globally is the Poco M3 Pro 5G, which has an ASP of $145. Now, of course, 5G democratization, as they call it, is key. Getting the 5G devices in the hands of more and more people. Of course, in the more developed markets, so North America, Europe, Northeast Asia, affordability is much less of an issue. So 5G has that availability to grow and become adopted by more and more people. In emerging markets, of course, where the total cost of ownership of handsets is a much greater proportion of income, these cheaper devices are much more important in terms of getting 5G devices into the hands of the people. So devices like the Realme Narzo 30 5G and the Poco M3 Pro 5G are going to become more and more important in growing 5G adoption over the next few quarters, next few years. And we expect, as 5G technology becomes even more affordable, that the handset devices will drop even further. So we are probably not that far away, possibly a year, 18 months away from a sub $100 5G device at some point. So thank you very much. That is the end of my presentation. Ganesh, back to you.
Thank you, Jan. That was excellent. I appreciate that. Now, moving on to the next speaker is Dr. Ben Guy from Melbourne, Australia, to present on the 5G smart construction. Over to you, Dr. Ben.
Thank you very much. Good evening from chilly Melbourne. All right, jiggity boo. So where the use of 5G is important to us is in the ability to capture this LiDAR technology, which is now available on the iPhones, to be used in construction and management of important and complex site works. So we're providing these gamified planning technologies into the construction market, into the infrastructure market, to enable people to set up real-time analysis of workers, plant and operational testing in environments that are very dangerous. So you can see here we have simulated railway lines, we have hyper-accurate environments, and then within that environment, we're using physics accelerated technology running on the GPU, which may be on the cloud. So latency is a very important issue. Access is a very important issue, and data streaming is a very important issue. These files can be terabytes in size. We run multiple cities. So we run all of Brisbane, all of Canberra, all of Melbourne, all of Wellington, all of Perth. These are cities of several million people each, where you can go into any environment and be able to test and plan the future in a realistic and understandable way. So what we have here in these couple of GIFs are some examples of being able to move into, what's a complex railway environment. For example, here on the left, this is accurate to about 5 centimeters. It's ground truth, so it's absolute accuracy to the world coordinates, although it's a Mercator projection, so it's a flat level projection. And what we're able to do here, we've been doing this for well over a decade at Urban Circus, is allow people to move inside these spaces and test, for example, a bike path, elevator positions, road layouts, pedestrian paths, billboards, We're even doing radar signals and curiously, and even actually 5G towers to assess coverage inside the urban environment, because obviously physical spaces and setup are quite important for the position of antenna. Here's another example in the top right. I just did a LinkedIn post on this very place. It's a place called Tamarama. It's next to a very famous beach in Australia called Bondi. People like to surf there. There's a television series called, it's called Bondi Rescue. I think Bondi Rescue, with lots of beautiful men and women running around. Anyway, so here we are testing out a bike path. So what the value to the market of that is that what would take months and sometimes years to plan and tests, you now do in real time on a virtual machine on a 5G network. See what we got next. Here's some construction. So it's the same concept. It's physics accelerated, gamified planning technology in the hands of the operator on the site. So here we are in photogrammetric data, which is captured in all these cases, no, in some of these cases by a drone, and some of these cases by a helicopter as part of a larger city model. So on the left, it's part of a 10,000 square kilometre city model of Adelaide. On the right, in the road projections along the bottom, it's a roadway. So what we're doing here is we're combining survey accurate data collected by the drone that morning, let's say, or that day, and then we're combining it with those purple lines there that we can see, which would be, okay, I've got a laser pointer somewhere. This purple, this is in the construction world, this is called CAD data or BIM data, which comes from engineering packages, and along with these red lines as well. And often the utilities underground are very important. Obviously, putting an excavator through a utility is not a good time. And then within this environment, we have a lot of requirements around keeping our workers safe. So here we are separating plant and people, and we're right down to planning and testing how we're going to operate on site at a particular point of time, live across 5G networks. We really need that level of data streaming and latency. Let's see what we got next. Okay, so here we have, again, several different types of environments running in different data. Here we are doing early pre-planning of the construction methodology. And for any of those who've done construction, things don't just appear. The future doesn't just appear. It needs to be created piece by piece. And oftentimes, for example, when building a railway line, such as we're doing here, you need to build a temporary railway line off to the side. It's a very important point, and it often is a great limit of where you can construct, because you need what's called a slew track, right? And sometimes you can do single, and sometimes you need to do double. So again, live, gamified, engineering-based, survey-accurate 3D environments is innovating and cutting the cost of planning for construction and design by hundreds of percent. In the same environment here, we're also, we have to do the shared user path, we have to do certain configurations, we've got certain cross sections in the environment. Here we are in a different, so this is more of a modeled environment, more traditional environment. This is an automatically generated LiDAR developed terrain model, probably accurate to 10 centimeters in that range. This one again is, this one here in the middle is a photogrammetric model of a place called the Sunshine Coast, very nice place. What we're doing here is testing out light rail alignment routes, so it's trams, okay? And all these conditions have vertical and horizontal curvature. That's very important based on the speeds. And so basically where these things are red, what I've done is programmed in the conditions, the top 10 civil engineering conditions that are required to comply to build something like this. Right down to hoarding levels and testing out we're going to do some temporary works and we've got to protect the neighbours or just plan some buildings around some highways, you can actually see here some sort of our smart traffic analytics for real-time simulation of traffic. Here we are testing, should we do a railway over or a road under? Road under sound better, but it actually creates all these conditions, edge conditions in the environment that make it kind of bad for the community, basically. So sometimes it's better to have a visible viaduct, as you can see it's going on over here. Another example is in the centre of Melbourne, where we're combining, again, in real time, 60 frames a second, utility data, civil engineering of major metro, and the combined building footprints of the new property developments, which obviously have a big impact when you're doing major infrastructure in very complex urban environments. We've been doing this project for well over 10 years. In a lot of this technology, what's missing is the human. And so we're very strong on getting the human into these spaces, into these environments, and being able to test right down to people need to test access. Where do I find the key to this gate for operational maintenance and testing? How do I keep this guy safe? And how do I run my railway lines? So the next layer, one of the next layers on top of this is you see the physical environment, but inside that physical environment are a whole bunch of invisible barriers, of course. There are a whole bunch of criteria. We're doing a lot of work in railway lines, as you can tell. So around the overhead wires here, so sometimes people die. It's all too common, unfortunately, by using an elevated work platform going up, then they move into the electrified wiring system. So there's obviously safety zones around that, and there's a bunch of rules around when you can get plant, how far you can get plant, like excavators close to these overhead wires, and how far you can get humans. And some pieces of machinery have intelligent GPS positioning and control, so you can get them a little bit closer. So all this becomes very complicated, and the poor construction managers and site supervisors have to often rebuild railways and turnovers and turnouts and crossovers in very short periods when we're all asleep at night in bed. These guys are out there from 11 p.m. till 5 a.m. very busily building these railway lines, and they get a lot of penalties if they're late in terms of the impacts. Another layer in this is adding parametric physics to complex scenarios, such as in this case railway signals. Down the bottom corner here, we're simply placing them by eye. Up here we've got parametric rules linked to the criteria for railway signals, which are quite a complex beast based on speed, conditions, sight lines. The center line here is the main criteria running up down the center of the track, and then a whole bunch of criteria inside the signals themselves that are physics-based, and again, being delivered in real time in workshops over 5G with major clients, such as MTR and MTM, people like this. I think I've already shown this. And then moving that down the pipeline through the circle, then we move into the community engagement piece. So we're taking this up to a level of rendering, demonstrating the quality of environments that we're building. There was a long time, 50, 60 years, where so much infrastructure, which was great, but just created a lot of urban blight. So actually a lot of economic depression around and adjacent to these. But you can see with these new pieces of infrastructure we're building with this real-time visibility high up the value chain, delivered to decision makers, the quality of the environments, the quality of the legacy that we're leaving for the next generation, as well as the sustainability outcomes, particularly in public transport, are very high, and just jacking up the evolution of what we can do thanks to a lot of the 5G network integrations that we're doing in really sophisticated environments like this, where we have major new expressways linked to busways, linked to parks, linked to massive filtration systems, and pieces like that. So that's what we're doing at Urban Circus. Thank you very much for your time today. If you are interested in how 3D planning technologies can help you in your environment, please do let me know.
Great one. Thank you, Dr. Ben. I appreciate that. Now, let's move on to the last speaker. I would like to introduce Masafumi Asakura from Tokyo, Japan, to present the Web3 technologies for industrial design. Over to you, Masa.
Okay, thanks. Can you see my screen?
Yes, sir.
Okay, let me introduce myself and my company. The final aim is blockchain technology, especially Web3, for industrial design and manufacturing. Our company headquarters is United States, and the subsidiary is Tokyo in Japan. And I'm co-founder and the chief executive officer of the Final Aim, and I was former chief operating officer around additive manufacturing and machine learning startup in Japan, which succeeded in being acquired by a company listed on the Tokyo Exchange in September 2017. The startup succeeded to fundraising from Global Brain and the Cyber Agent and other individual investors. And previously, I lived in Singapore 3 years as a managing director, and my first career as a Mizuho Bank as a bank clerk. Main client was manufacturing industries. Okay, and who we were. The final aim is driving the adaptation of blockchain technologies for serious business of industrial design and manufacturing. As collaborating with enterprises like Panasonic and Autodesk and those type of multinational companies. In this industry, 5G technology is very important. The reason why it creates a lot of the 3D modeling data, and in the case of the Web3 technologies, the timing of the connected to the metaverse, the 5G is very important. And the characteristic of industrial design and manufacturing, and in the case of the industrial design, exceptional level of stakeholders and a long value chain is required. However, monetization points are limited and the ratio of gross profit are not high. This is a characteristic of the industrial design. And however, I and my team know the detailed insight about the industrial design market, and this in this problem, we have the countless value-like ideas, asset, and opportunity missed and overlooked. It's very important. For example, the concept ideas and the intermediate designs. For example, it was printed by 3D printer, and the project participation, for example, Formula Car, and the idle manufacturing as a machines, not only just the prototyping, but also the mass production. And especially in the case of the 5G technologies, and the utility design asset across other industries, especially metaverse, it's very important. Our solution is very simple. As a streamline and create new customer touch points and brand engagement and monetization points. It's 3 steps. Our first step, add value by blockchain, and the second, liquidate value by tokens. As a third, circulate value via communities. These 3 steps for our solution. And we have a product and collaboration platform to manage industrial design and manufacturing with Web3 technologies. such as blockchain and the smart contract, the IPFS, it's a peer-to-peer network, and the tokens, especially utility token. We manage several of the industry design draft and the 3D modeling data, and the issues of utility token. And for example, we have already cooperated with Panasonic as a Web3 partnership project. And in the case of the Panasonic, their users' committed asset has been fully capitalized. We will utilize Web3 for the solutions. The total number of cloud Panasonic is around 8 million. We are going to collaborate with those types of existing as communities. And our projects are already featured in the most influential media in the industry design, the name of the axis, magazine axis. And in the point to the global collaboration in the US and Germany and Japan, we have already collaborated with Autodesk, the leader in 3D CAD software companies. And last year, we collaborated with Autodesk in Germany as a utilized the Web3 platform at Formnext, the world's largest exhibition for additive manufacturing in Germany. In that timing, we use our product. And in this year, we were invited to introduce our Web3 platform at a global conference at the Autodesk Accelerator. The theme was Web3 technologies for industrial design. In that timing, we collaborated by design with the Japanese traditional sword craftsman generative designs stored on IPFS, the peer-to-peer networks, and every additive manufacturing and 3D printed file has been certified by blockchain to prove its originality and integrity. And furthermore, this unique certificate record is 3D printed physically on every model. And by representing the sword design by NFT technologies, non-fungible tokens, it can be seamlessly imported to the metaverse without the worry of copy and losing control of the design data. In this field, the 5G technology is very important. The reason why speed is very important point for metaverse. And the designers can host galleries to enjoy immersive interaction between remote client users. And additionally, the designers can distribute their design by non-fungible tokens, value authenticated with physically 3D printable design, creating new business opportunities. And as an example, as a case, with iMatrix Japan as a 3D facial scanning eyewear brand originated in Switzerland, the final aim secure the personal data with integrity and full ownership to users. The verification deepened and expanded to consider new opportunities, capitalizing on the data set to emerging markets, such as digital manufacturing, as the AR and VR, and the metaverse. And we have already applied the multiple patent application from the perspective of intellectual property and the business variation as the digital manufacturing and the supply chain management. Yeah, thank you for your time, everyone. That's all.
That's great. Thank you so much, Masafumi Asakura. I appreciate that. Let's take some about say 10 minutes of our time to see if we can have a quick Q&A among the speakers here. If anyone have any questions from the presenters, maybe I could able to start with one of favorite question here. I believe all the speakers are very well versed in their technology domain and also working with their own partners SIs or maybe with their clients or even with the telco partners. If any of the speakers would want to say 1 or 2 points, what are your key challenges that you are facing currently, particularly in your selling or deploying or building the 5G product or networks? Anyone wants to share the pain points or challenge?
I think maybe I can go first, just from a smartphone adoption point of view. One of the main challenges we're seeing at the moment is the general macro climate, the economic conditions around the world, geopolitical challenges, etc. So inflation is at record levels in many countries around the world. Cost of living is on the rise. Many countries are at the risk of close on the brink of recession. We also have geopolitical concerns and tensions in Russia and Ukraine, for example, China, Taiwan. There's a lot of unease and uncertainty around at the moment. So from a 5G smartphone adoption perspective, that is definitely slowing things down. The industry was already in a difficult and an unbalanced place already because of the pandemic, the COVID pandemic, and then also from chip shortages. So the industry was on the way to recovery from that, but then these new macro concerns around economic issues and geopolitical issues have hampered that recovery. So in Q2, for example, we've seen an 11% decline, a year-on-year decline in shipments in smartphones. And we expect those challenges to continue, and I think those challenges will probably expand into other sectors as well. Hopefully that helps answer the question.
Great. Anyone wants to add anything?
Yeah, maybe I will just, I think I should agree. And I was about to say about Jan's comments about the chip. I think the bigger transformation programs are more or less impacted by the supply chains and the chip shortages. And as we all know, right, when it comes to some of the enhancements coming in the hardware, let's say Intel Sapphire Rapids, and same is the case for ARM, right? Their availability are delaying some of the advantages, which obviously we are expecting to solve, right? So I think that's the one thing. And going to the other side, specifically, I see in terms of vertical adoption, right? Vertical industry. I think this is not something new, but again, I want to reiterate that the success in the 5G vertical and many of the innovations, right, that can really come when all of those Toyotas and Hondas and maybe these Boeings of the world really embrace it and their voice is heard. Still, I think we have gone far, but still how this vertical industry can speak about 5G and how we can monetize. I think that can really help us to accelerate this. So yeah, that's the 2 points from my side. Thank you.
Great. Thanks, sir. Anyone else?
Hi, the Masa, the fire as in the case of our company, the challenge is the adaptation of the digital transformation. The reason why the industry pain point is especially industrial design and the digital manufacturing. Even artificial intelligence are a little bit tough to adjust, especially in Japan. So for me, is adaptation about the digital transformation is the first step. And the second step, to adjust for Web3 technology is a little bit tough in this timing. As a reason why it means that knowledge about the DeFi or the several tokens, those type of the specific the knowledges, I think it needs a step-by-step as a solution. It's my insight. Thanks.
Thank you, Masa. Anyone else wants to highlight anything? Or you have any question from any other speakers? If not, then I would like to thank all the speakers for joining us. Your contribution is very value added for us and also for the audience, mainly the operators, telco vendors, the vertical startups, the universities as well. So I think it will be a greater reach out via the YouTube channel Global 5G Evolution. So to the audience, please don't forget to click subscribe button on our channel. And thank you so much for joining us. And I really hope we could able to
Okay, that's it, everybody. Thank you very much. I'll end the meeting.
Thank you very much.
Thank you, everybody.
Thank you guys. Thank you.
Thanks a lot.
Thank you,
Take care, everyone.
guys. See you next time.
Next
Bye-bye.
time. See you next time.